Sometimes people ask me, "Yo, Mr. Copeland, why are you a teacher?" And I respond, it's because I like tormenting students with lessons like this one. Okay, so we're doing rational equations, rational expressions, and the most important thing you're going to have to know for this entire unit is you must be able to factor completely. End of story. You can't do that, you're going to get stuck. So, and you got to factor tops and bottoms of every fraction, ugly looking fraction you're looking at. Now, once you've done this, for what we're going to be doing here right now, we're either going to be multiplying these fractions or we're going to be dividing them. And you handle them, depending on what you're looking at. You handle them one way or the other. When multiplying, you just multiply straight across. And when dividing, you change the division into multiplication, and then you flip the second fraction only. So in both situations, you're going to end up multiplying straight across. However, when you start as a division problem, you need to flip that second fraction around, and then you multiply straight across. But before you multiply anything, you should always check to see if there are any common factors on both top and bottom anywhere that you can cross out. So let's see this, because seeing is much better than hearing. I want to multiply these things. Okay, so I need to have them factored completely, and good news, since they're monomials, it's pretty much factored anyway. But yeah, the first fraction looks fine. I do notice that the 15 and the 8, the actual coefficients there, I could kind of factor just those numbers real fast. And the reason I want to do that is because it'll make simplifying the rest of this a little bit easier. So the 2x to the 4th, the y to the 5th is just fine. The 3x squared is just fine. But I'm going to go ahead and make that 15 a 5 times 3. And of course the x squared is fine. And I guess I'm going to go ahead and make that 8 a 2 times 4. I still have the x cubed and the y squared. Now the reason I would do something like that is, as I said, I want to look across the tops and bottoms of all of these and see if I have things I can cross out. Well, there's a 2 on top here, and there's a 2 on bottom here, I can cross it out. If there's a 3 on bottom here, and a 3 on top here, I can cross it out. So that saves me a little bit of effort, because I could cross out some of my stuff for my numbers. Now I can do a similar thing with my x's and my y's. For example, I'm noticing an x squared on the bottom here and an x squared on the top over here. Those are going to cancel. And then I see an x to the 4th on this one and an x cubed down here. In that situation, they're going to cancel in that you subtract those exponents. So x to the 4th, x cubed. If I subtract the exponents, that's just an x. And then y to the 5th, y squared. Subtract those exponents and it'd be a y cubed. So that takes care of my letters. I've dealt with this and this. I've dealt with this and this. The only thing I haven't dealt with is this 5 and the 4, so that's part of my answer. The 5 would be still on top, and the 4 would still be on bottom. And there you go. It's multiplied and it's simplified. However, there's one additional thing we need to talk about, and that's values of x, or in this case also y, that would make this undefined. Meaning, remember, you can't divide anything by 0, so you always need to check what could I plug into x to make either of these denominators 0. Well, pretty simple. If I plug in a 0 to 3x squared, 3 times 0 squared is 0. That's a no-no. So x cannot be 0. And I do the same thing over here. And yeah, if I plugged in a 0 into x, that would be a no-no. Well, I've already got 0 covered for x. And for y, same thing. I can't plug in a 0 to that. If I plugged in 0 into y right here, no matter whatever x is, 8 times anything times 0 is 0, and that's a no-no. Can't divide by 0. So as you go through these, you will have to take a moment to reflect on values of x that or y that you can't use because you can't divide by 0. Okay, so now this is actually going to be a little bit more like a common type of problem that you're going to be dealing with. in that I really need to go in and factor these polynomials, and then I'm going to cross out any common factors, and then I'm going to multiply. So starting with this top numerator over here, 10x minus 40 has a common factor of 10. So pull out the 10, that would leave me with x minus 4. That's factored. Now to the bottom. Different factoring technique. This is a trinomial. I'm going to use the M&A method. What multiplies to 8 and adds to negative 6? That would be negative 4 and negative 2. So then in factored form, if it's negative 4 and negative 2, it'd be x minus 4 and x minus 2. And then on the right hand side, the x plus 3 is factored just fine. But then on the bottom, I'm noticing 5x plus 15 has a common factor of a 5. So I pull the 5 out. Divide 5 from both of those, you'd have x plus 3. Now, once you've factored, it's actually a good idea to go on ahead and state what values of x are no-nos that would cause me to divide by 0. And that's going to be pretty simple at this point. Just look at the factors on the bottom there, only the bottom right now. And what would make this 0? Okay, positive 4, positive 2, and negative 3. That's 3 things that x is not allowed to be based on what my denominators are. Because again, I can't divide by 0. And if I plugged in a 4, a 2, or a negative 3 to any one of those anywhere, then it would be divided by 0, and that's a no-no. So I'm going to write down x cannot be equal to 4, 2, or negative 3. Now that I've got that out of the way, let's go on ahead and, before we multiply things straight across, let's identify things that I can cancel. For example, x minus 4 and x minus 4. Those can be canceled. And, oh look, x plus 3, those can be canceled. And the 10 and the 5, well 10 can be divided by 5, and 10 divided by 5 is a 2, so I'll leave a 2 on top. And actually, that looks like that would be the only thing on top because I canceled these other things. So 2 is the only thing on top. And then on bottom, it looks like the only thing I have left is this x minus 2. So believe it or not, this really ugly looking mess of fractions times each other, once all simplified, is just 2 over x minus 2. And notice what we're doing as we're simplifying this here. By canceling these fractions first, or not fractions, canceling these factors first, it made my life so much easier. This is why it's important to factor completely, because I get this answer very simply that way. Now let's talk about division. So remember, division has that one extra little step to deal with first, that you have to change division into multiplication and you flip the fraction around. So let's do that. I'll go ahead and I'll save the factoring to do second. So x to the 5th minus 4x cubed, all this stuff is the same, but we are changing the right fraction to be the other way around. So that means the x squared minus 1 is on top, and the x to the 5th minus x to the 4th minus 2x cubed is on bottom. Okay, so let's factor. Starting with the top left, I see a common factor of x cubed, so I'm going to pull out the x cubed. And in doing so, pulling x cubed out would give me an x squared and a minus 4. On the bottom, x squared minus 2x, x squared minus x minus 2 is a multiply and add method. So the multiply number is negative 2, the add number is negative 1. That would be negative 2 and positive 1 are my numbers. So if it's negative 2 and positive 1, then that's what that looks like in factored form. On the right hand side, x squared minus 1 is a difference of squares, so x squared minus 1 becomes x plus 1, x minus 1. Again, that's just an automatic little thing. And then on the bottom, I see x cubed is a common factor, so I'm going to pull out an x cubed, which would leave me with an x squared, and pulling x cubed out of this, leaves me with an x squared. X cubed out of this would be a minus x, and x cubed out of this would be a minus 2. Okay, well that was all good and fine, but guess what? We still have more factoring to do, because looking back, I can see that this is a difference of squares, so it can be factored more, and I can see that this is a M&A method, actually the exact same thing as I did a second ago, so I already know what x squared minus x minus 2 is going to factor into. It's going to be the same thing as it was the first time around. So let's go ahead and deal with the difference of squares one first. I still have the x cubed, but now x squared minus 4 becomes x plus 2x minus 2. That's your difference of squares technique. Nothing changed on the bottom. Oh my god, Mr. Copeland, this is too much math. I give up. Deal with it. The x plus 1, x minus 1 is fine. Remember we said this other one that I highlighted, that can be factored. It actually happens to be the exact same thing as it was on the original left-hand side, so I already know what it becomes. It becomes this same thing, x minus 2, x plus 1. If you're not sure, use the M&A method. Alright, completely factored. Now, let's cross out, well actually before we cross out common factors, let's state what x cannot be. So looking at across the denominators, I can see that x cannot be 2. I'm going to write it down here. X cannot be 2. X cannot be negative 1. X cannot be 0. We already said 2. We already said negative 1. I don't need to repeat them. But there's a little catch to this. Remember that the original problem was a division problem. And I can't divide by anything that would be a 0. So actually, I'd have to worry about this being a 0 as well, which is the top of this one right here. That means I also, when I have a division problem, I have to consider what can make the top of this second fraction also 0, and include that in my no-nos for x. Okay, well x can't be negative 1, got that covered. X can't be positive 1, I need to write that one down. So if I don't catch that, then that would be one of my x's I would have missed. Okay, now we finally can cross some stuff out, and this is the easy part, folks. I just look to see what matches where. An x cubed here, an x cubed there, gone. An x plus 2 here, I don't see neither x plus 2's. X plus 2 is fine. But x minus 2 I have here and here. And then this x plus 1 down here, I see one of them up here, so I can cancel that one. And let's look real carefully. Do we see anything else that could cross out from a top or bottom anywhere? No, the x plus 2 is fine. This x minus 1, I don't have any other x minus 1 on bottom. And that's it. So that's all the things that could cancel. So now I can multiply straight across, and that would be my answer. So x plus 2 multiplied straight across times the x minus 1. Okay, so that's my new numerator. And my new denominator is just this x minus 2 times x plus 1. And we're not going to FOIL that. That's too much to deal with. I want this in factored form. So please, when you multiply straight across, just leave it in factored form. That would be a-okay. Long video, but it's, a lot of factoring, so it takes a little while. Go back and rewatch it if you need to, and I'll see you in class, and we will be practicing this faux show.